Hello there, viewers. This is Ricky Klein, the Cassette Master, here to present to you another recorder. A Soviet cassette recorder. The VESNA 306 2-speed cassette tape recorder from 1974. I hope you will enjoy this presentation. Shot on the 10th of May, 2020. First things first, I want to do a bit of shaving, okay? I'll be back. Oh, freaking gee whiz, huh? Yo, Boone, I'm back, brother. And you can see I shaved a bit. Now, lights, camera, action! That's right. This is your host, coming to show you the VESNA Spring 306. VESNA, I believe, is Russian for spring. A very nice cassette tape recorder from 1974. In 1971, there was going to be a recorder introduced in the Soviet Union, the VESNA 305. They wanted to incorporate a special three-phase motor. But do you think three-phase? Isn't that AC? Three-phase AC motor? Heck, households don't even get three-phase here in America, although I don't know if they did in the Soviet Union. Three-phase is typically used for industrial purposes, right? Well, they wanted to use three-phase motors. But we're not talking high-voltage three-phase. We're talking about low-voltage three-phase off a battery-powered portable with a special control circuit. That is a three-phase brushless motor. But developments of that motor were taking longer than expected. It was an engineering challenge. So in 1971, the VESNA 305 was introduced, using a Japanese imported DC motor. Finally, in 1972, they had finally finished the design of the three-phase Soviet small motor, and the VESNA 306 was introduced, using that motor and incorporating two speeds, 4.76 centimeters per second and 2.38 centimeters per second, aka the speeds of 1 7/8 inches per second, the standard cassette tape speed, and the half speed, 15/16 inches per second. This is the VESNA 306, using the three-phase motor. Now, these three-phase motors weren't known to be the most reliable, and it was common that those motors would end up getting replaced later on down the line with regular DC motors because of the unreliability of the motors. When I got this machine, it was no exception. What was the problem? Motor wouldn't even bother to turn. The shaft was so frozen solid I could barely turn it. I had to use a lot of force just to make the thing turn. Took the motor apart, saw the ball bearing assemblies were held in with rubber or one of the ball bearing assemblies was held in with rubber, and the shaft always being pulled by the belt in one direction made the rubber deform, so the shaft was kind of crooked. I replaced that rubber ring with another rubber ring that I took off of a little grommet, to hold an AC cord. Good grief, open the right drawer, idiot. One of these little grommets. Shaved some of the rubber off, stuck it around the ball bearing, and was able to fix the motor. Motor's not perfect, but it does run now. And the speed's able to be regulated by the motor. Although there is a bit of flutter, though I'm not entirely sure if that is due to the motor or just due to the belt, because it still has the original drive belt in it, which amazingly enough is still tight. It's just a bit deformed from being in a particular shape for all those years not running. But the motor is operating now. But another problem came up. The machine had an unusually high amount of current draw. Now, one of the things about the three-phase motors they were wanting to use on this recorder was to have lower than normal current consumption. That is, lower current consumption than you'd have from a DC motor. But this was drawing a lot of current, a good 600 milliamps, 700 milliamps. I even saw the ammeter spike an amp from time to time. And one of the transistors on the motor driver board was getting really freaking hot. After replacing that transistor, the new transistor barely got warm and the current draw went way down. So now, working with the original Soviet 3-phase motor and driver circuitry, sans a replaced transistor, is the VESNA 306. Though when you're used to reading English, you read that, it looks like it says, BECHA. So you want me to show you this recorder? You betcha I'm going to show you this recorder. Prepare for flutter.
Hello there, this is your host, coming as usual, making a recording on the VESNA 306 cassette tape recorder. This particular Soviet cassette tape recorder is from the year 1974 because the date is stamped on the inside of the machine, and many of the components' date codes also have 1974 date codes. This 2-speed recorder right now is running at 4.76 centimeters per second, also known as 1 7/8 inches per second. This is a manual level control recorder. Whenever you're recording, to not hear the sound of the recording, you have to turn the tone control all the way down until it clicks to 0. Because whenever you unclick it and turn it up, you'll be monitoring, and then you can make it feed back. Another interesting switch that you don't typically see on tape recorder is a wattage switch. 1 watt or 0.5 watts, where you can switch the wattage of the audio amplifier. I'm guessing that one would switch it to 0.5 watts when they wanted to conserve batteries. This is manual level control only and boasts mechanical pause. I'm very pleased that it has a mechanical pause function. Because it's, of course, a more smoother transition than an electrical pause. Being manual level control, I now have set the level all the way up. And I'm now speaking at arm's length distance. Now we'll set the level down lower again so it doesn't overdrive. This recorder is AC bias and also AC erase. Therefore, has a very low noise floor. I always like the low noise floor of both AC bias coupled with AC erase. It makes for a very pleasant experience. This recorder has a frequency response of 63 Hz to 10 kHz at 1 7/8 inches per second, and at the half speed, the frequency response is 63 Hz to 5 kHz. And also, thank you very much, this recorder does indeed change the equalization for the lower speed. Now, let's set the speed down to half. The machine is now being ran at 2.38 centimeters per second, which is the same speed as the standard faster speed of a microcassette. Since this recorder does change the equalization, it does have fairly good frequency response at the slower speed. Now, unfortunately on this unit, I don't know if it's the original motor still not being perfect, or if it's the belt still being original, or if it's those two working together in tandem, but there is a noticeable fast flutter, which is quite severe. So that is a downside, at least with my unit. But aside from that flutter, the sound quality is pretty good, and indeed makes great for voice recording, save for the flutter. This recorder could be used to make tapes that could be used to play on talking book machines, although, of course, only a side A and a side B, because it is not 4-track mono like a talking book. It is your standard half-track mono, typical for cassettes. And now we will have music. I got a text message on my smartphone. We will have music now, but first we will go back to the regular speed. Well, you should be back at the regular speed.
Команда новой формации на космическом корабле. Оперируй информацией, как никто из людей на Земле. Теоретики мы и практики, повышая свой интеллект, бороздим просторы галактики, бороздим уже много лет.
Yeah, the flutter is just as bad at 1 7/8 as well. It's unbearable, but I still wouldn't be surprised if it is the motor that's causing the flutter more than the belt. I want to think it's just the belt. I want to believe the motors still have life, but it's probably not ever going to perform as well as it did when it was new. Now we're doing music at the half speed.
Честно, что уже в двигателе дела пошли неважно у меня. А в окончании шахматный компьютер имел запешку целого коня. И я со зла ему в ответ воскликнул: дерзкая железка, тебя сотру я в порошок. А он ответил:
Anyway, aside from the flutter, it's a really nice recorder. Has a nice large oval speaker in it as well, which I really enjoy. It has a good bass. And here's the rear of the recorder. And if you look up here, you can see model and voltage information. Believe it or not, it will actually run on 127 volts as well as 220. To change the voltage, you unscrew this the screw in here, pull the connector out, and then flip it 180 degrees, making sure to put the fuse in the other slot. I don't have a cord that fits it though. I have a similar cord for another machine, but it just barely doesn't fit. Murphy's Law, am I right? And also this recorder runs on 6 D cells for a total of 9 volts. So anyway, the presentation of operating of this recorder's section of the video is now over. However, I shot footage earlier of the machine when it was opened, showing the internals and so forth. So that footage will now be being shown, which of course has been shot at just the other day, and yesterday too. So hope you enjoy it. Now, I don't know when this will actually get uploaded. It's right now May the 10th, 2020, but I might not feel like editing it just yet, or I might. Depends on my mood, bro. But hey, when you see it on YouTube, you'll be seeing it, brother. And I want to give a shout out to Speaker Freak 95. He may have saw a text message where I said, he asked me if I wanted something, a particular amplifier, and I said, "You betcha I want that." And I put BECHA because the VESNA looks like it says betcha. So I told him it's foreshadowing, and well, it's foreshadowing this. That's why I said betcha. Oh, hope you enjoy. Well, this isn't the end of the video, though. It's just the end of this section. I'm just chin wagging again. I do that a lot. My friend Zap, he says I ramble. I ramble a lot. So, anyway, and I, of course, another deal with a shout out to Speaker Freak is the fact that I'm using a Shure SM57 microphone hooked up into the camera boom mic. And speaking of booms, I got 2 boom lamps. Just recently got these lamps. So I added them to the workbench as well. These are very nice boom lamps. Fluorescent, of course. They were getting rid of them at the workplace, so they have come to have use over here. And now you can have a nice illumination. I mean, yes, sure, I already have this big fluorescent light above the workbench, sure. But sometimes, you see, I might be showing something at an angle like this, and you have the light coming down straight on it. And you can see the top really nicely on the camera. And then the front of something might be dark. So I can shine the light kind of at the front as well to illuminate it a bit better. And plus, if I need to use a magnifying lens, that'll come in handy, or if I need to relight something up really close, or something that's at an angle. Now, of course, when I shot the earlier footage of the inside, I didn't have these boom lamps set up, so I apologize for the dark view of this side of the motor control board. We had a shaft that was not wanting to turn easily on this recorder. The Soviet recorder here. I have the motor popped open, thought I'd show the inside of it. This is not a DC motor. It's a small AC motor. I think it's a 3-phase motor, which requires a special complicated driver circuit, which is on all the circuit board here. Is a driver circuitry for the motor. And I bet the ball bearings are probably just not wanting to move easily. It's all gummed up in there, nasty. You can see in the bearings there with this little Soviet motor. I'm going to try putting graphite lubricant in there. It's this lock fluid here. I'm going to try to see if that will free them up. Hopefully we can get this little machine to work here. Pretty interesting. Put the lubricant in, put the motor back together. The shaft was turning, the motor was managing to run, but it was drawing a lot of current. The motor was getting hot, and the motor was very noisy. And the driver transistor was also getting really hot, and the motor speed regulation was absolutely atrocious. I don't know if you may have noticed earlier, but the ball bearing inside there was off-center. It had rubber around the ball bearing, and I guess because the belt had been constantly pulling on one side,
for a long time without it turning. It had just pulled the ball bearing. Well, even if it did turn, it had been pulling on one side for so long. The rubber had deformed over time, and then of course all hardened and so forth. So I took the ball bearing out. I got an old grommet, one of these little grommets here. I kind of cut off the flanges and made it something like this and put it around the bearing, and now it looks like it's a bit more centered. So we're going to try that, see if that works better. You can see how the transport mechanism is on this recorder. Some of it's fairly conventional looking. The central roller here is for your rewind and fast forward. There's your rewind and your fast forward. Motor, after putting the new rubber on it, although it's not perfect, it's definitely operating a lot better than it did before. Let's turn the unit on. Drawing right now, the motor being sideways. Its current's going around a little over 400 milliamps. I'm going to load the shaft a bit here. Let go of the shaft and put the motor facing down. A bit less current when it's facing down. When it's sideways, it draws a bit more. But anyway, the motor's definitely operating now, which is good news. Definite improvement from where it was. Especially considering when I first got this recorder, the motor would not even try to turn, and it took a lot of force to actually be able to rotate the shaft. A lot of force with my fingers, that is, to rotate the shaft. Yeah, it is a very noisy motor. That is for sure. That transistor gets spicy hot. Wow. These other transistors don't get that hot. This one gets super hot. It's crazy. Oh, I saw it draw 0.66 amps at one point. Oh, jeez. A lot of current draw from this motor. My gosh. Okay, so good news everyone from Professor Farnsworth of Futurama. We have improvement in the current draw of this recorder. You might remember before the current draw was going up to 600 milliamps, 700 milliamps. I even occasionally saw it spike just over an amp for just a moment. Now the current draw is probably maximum I'm seeing is the occasional 350 odd milliamps, but it's usually running lower than that. We had this transistor here that was at the edge of the circuit board that was just getting steaming hot. It was getting so hot, I'd touch it and it's like, ah! You know, it burned you pretty much. This thing was steaming hot, this transistor. It's a GT403B. Of course, in the acrylic, it is that. And I found the data sheet, so I was able to find the base collector and emitter, find the pinout for the transistor, and that's the pinout for the transistor. Looking at the bottom. So with this transistor, I took it out of the circuit because it was getting super hot, and I was curious. You know, I wonder if the motor will still run with the transistor out. Let me just see what happens when a circuit runs with the transistor out of the circuit. I took the transistor out of the circuit, and I turned the machine on, and lo and behold, the motor came to life, and it continued playing the tape. And the current draw was a lot less. I'm like, what? It's still working without the transistor? Then I rewound the tape a bit, went back to play it, and then it wouldn't. The motor wouldn't turn on. tried it again. The motor wouldn't turn on. And so with it out, the current draw was drawing a good 440 milliamps and the motor wouldn't turn on. So that gave me the impression that this transistor is probably used to give an initial start to the motor. And once the motor is started in motion, it's no longer needed in the circuit. But I'm imagining probably for some reason the transistor was stuck on in the circuit and not turning off. Maybe some aging capacitors or some other problem, drifting values may have caused the or maybe the transistor itself was going bad and staying on and not turning off on its own, and it was just sinking a whole lot of current. It was getting super hot, and so I was just in my troubleshooting. I grabbed, since I got the pin out, I grabbed an old Texas Instruments 2N404 transistor I have lying around. I have a bunch of just these old 2N404 Texas Instruments PNP germaniums, and I just stuck one in there just to see, just for kicks and giggles, you know, and to see if it's if that, just kind of to basically to make sure my pinout was correct with a different transistor in there, see if it would start the motor up, and just to see what happened. And I put that in there, and I couldn't believe it. It started, of course, I mean, it started the motor up. I was expecting that because the transistor, I imagine, gave that motor that initial go, you know. But then it became, it was operating correctly. The motor, the current draw was a lot lower than it was with this transistor, and the transistor was not heating up. So I'm just going to go ahead and leave that Texas Instruments 2N404 transistor in there because that caused this to, it fixed the problem. So yeah, it ain't a Soviet transistor, it's an American one, but hey, you know, sometimes you got two countries that want to nuke each other back in the Cold War days, and sometimes the enemy's transistor will fix the problem. So, and then I'll have this little Soviet GT404B power transistor just in my spare parts, just assorted transistors, and that solved the problem. I'm very pleased. I'm pleasantly surprised. The downside of the original motor is there's still a fast flutter, most noticeable at the slower speed. Of course, having the original belt in there doesn't help. The belt is a little bit deformed, of course, because it had been sitting in one position for years. But it's able to run now, and it's not drawing nearly as much current as it was before, so that means I should be able to run this machine for a longer period of time without worrying about burning the transistor up, and be able to run it on batteries without worrying about draining the batteries super duper quickly.
This has been a Cassette Master production.